So 17.2, law of sines and area of a triangle. I just want to go through a little bit really quick. Your quiz on Friday, it says 17.1 through 18.0. 17.1 were the notes that we did the first day. Those are your SOHCAHTOA notes. Okay. 17.2 is what we're doing today. 17.3 is the next page. It's called the law of cosines. We are actually skipping that this year. We're not going to do 17.3, which jumps into 18.0, which is that special right triangle stuff that I was talking to you about. Okay, so it's basically the first 3 pages of your packet is what your quiz is on. Okay, so law of sines and area of a triangle. We're going to start off with the area of a triangle. Get a highlighter. And then we're going to move into this law of sines thing. So 2 things that we need to learn how to do. Before I go any further, I don't want to forget to mention that your homework is out of the textbook. I will be posting the textbook document, you know, the PDF of it on Google Classroom for you to use, as well as the odd answers. And once again, if I post the odd answers and you turn in a homework assignment that only has answers for the odd ones, you're not fooling me. Okay? Make sure you have work to support your answers on all those guys. Okay? All right, now, both the law of sines and the area of a triangle have a formula to them. You do not need to memorize the formula, though. You just need to memorize how you have to set up your problem. Okay? So the area one, I have 3 different ways that this formula is listed, but you don't need to memorize them. Okay? One of them is 1/2 BC sine A, 1/2 AC sine B, 1/2 AB sine C, and so on and so forth. What do you know? Let me step back for a minute. What is the difference between the capital ABCs and the lowercase ABCs?
Capitals are the angles.
Capitals are the angles, lowercase are the sides. Yes, and that is always going to be the case. So with each of these, you have 2 sides first, and then you're taking the sine of an angle, which makes sense. You can't take the sine of a side. You can only take the sine of an angle. So how are they related? Well, if you have side A and side B and side C, well, guess what? Side B and side C are the 2 sides that make up angle A. So if this is side B and this is side C, angle A is the angle right between them. Okay? So if this is side B and this is side C, this is angle A. So all of these formulas are saying you take 2 sides, well, you take 1/2, multiply it by a side and another side, and then the sine of the angle that is made up by those 2 sides. Okay? Now, why is it important not necessarily to memorize the formula, but to understand where the formula comes from? Because we're so nice to give you ABC, 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 and then our first example has DEF. Well, that kind of screws you over if you just have a formula memorized, right? So, what I'm going to do for the area here, all of the formulas start off with 1/2. By the way, what was the formula for a triangle you used to use? 1/2 base times height, right? That becomes a little bit of a pain in the butt in a triangle like this because the height of this is a pain to find. Okay, so this formula actually I think is easier to use than the 1/2 base times height, personally. So 1/2, I need 2 sides. Give me 2 sides. 7 and 7.5. And here's the side of 7. Here's the side of 7.5. So I have to do the sine of the angle that is made up by those 2 sides, which is angle D, or 141 degrees. Does that make sense? So from there, I just go to my calculator. Make sure you have your calculator out. 1/2 or 0.5 times 7 times 7.5 sine 141. And you can just type all that in because no plus or minus signs or multiplication signs automatically means multiply. And I have 16.51. We're going to call that 16.5. Now, I do need to label my answer. So we are talking area, so whatever the label is has to have a squared with it. If we are talking inches like we are in this problem, my answer is going to be inches squared. If you're talking feet, you're going to say feet squared or square feet. If you're talking meters, you're going to say meters squared. Area always has that squared with it. Pretty easy? Okay, let's look at the next one. Next one's a little different because they give me two sides and they give me two angles. Do they give me the angle that's included between those two sides that they've given me? No. So should I find this other side over here and then maybe use this angle and the two sides? Or this angle and the two sides? I could. How would I find the length of that side? I'm so glad you said that because that's totally wrong. But I'm so glad because people would say, oh, I need to use Pythagorean theorem for that. Why can't we use Pythagorean theorem here? It's not a right triangle. You can only use Pythagorean theorem in a right triangle. So I'm glad you said that because people need to be reminded that you can only use that in a right triangle. Okay? So, since they gave me two angles, it's actually super easy to find that angle, isn't it? I just subtract them from 180, right? Because they all have to add to 180. 180 minus 80 minus 45 gives me 55. So this is 55 degrees. I can set up my area formula. It'd be 1/2 times what? 10 times 12.9, and it doesn't matter if you put the 12.9 first or the 10 first, times the sine of what? 55 degrees. Because the 10 and the 12.9, that's the angle that they make up, so I have to use the sine of that angle. So again, going to my calculator, 1/2 or 0.5 times 10 times 12.9 times the sine of 55, and that gives me 52.83, which I'm going to call 52.8. I know you can't see that very well, but there's your 52.83. 52.8 what? Yards squared. Okay? Now, I'm not going to give you the formula on the quiz on Friday because these things right here, the A's, B's, and C's, we didn't actually use, right? You just need to remember it's 1/2 times side, the angle between. Okay? So that's what you're going to have to remember for that. Any questions about the area stuff? No? Good. All right. Next thing we're going to do is law of sines. Law of sines is a bunch of fractions. And it's always the sign of the capital letter over the corresponding little letter. Now, what does that mean as far as a bunch of fractions? Well, I'll show you when we get to an example. It works in cases where you know two angles in any side or two side lengths and a measure of an angle that's not between them. We would call that side angle. Okay, so again, here's a formula. You don't need to memorize it. You just need to know how to set up a problem. Okay? Because again, here's a formula with A's, B's, and C's, and my first example is DEF. So nice of me. Two things I need to find here. I need to find side EF. What lowercase letter would I use to label side EF? Side EF is right here. It's directly across from angle D, so I would call this little d. Which side would be labeled little e? 20. And which one would be little f? 15, because again, it's the side directly opposite the angle. So? I want to do the area first because I think that's going to be pretty easy, right? 1/2. Let's use the two sides they've given me, which are what? 15 and 20, times the sine of, what's the angle between 15 and 20? 56, so that's the angle I use. So let's plug that in and we'll have our area really quick. 0.5 times 15 times 20 sine 56. I get 124.35 rounds to what? 0.4, and how am I going to label this? Miles squared. So there's my area. So find side EF and the area. Area's done. Okay? All right, so here's how the law of sines works. One of my fractions always has to include the side or the angle that I'm looking for. So one of my fractions is going to have to include 56 degrees and little d. So it's going to be sine 56 over little d. Once I have a fraction that has what I'm looking for in it, the other one, I have to know both the angle and the side opposite. So I could use, actually, well, this one I should use f because it's the only other one where I know both the angle and the side. This one, they technically don't give me the angle, so I wouldn't want to use that one. But you can use either of them. So I'm going to say sine of what? 47 over what? 15. Once I have that set up, how can I solve that? Cross multiply. Every single time you use law of sines, you can cross multiply. So let's see, I would have d times sine 47 equals what? That equals that. 15 sine 56. And if I'm looking for d, how do I get d by itself? Divide by sine 47. So d is equal to 15 sine 56. I like to hit enter there just to see where I'm at. Divided by sine 47. And I get 17.00, which I'm going to round off to what? 17. And what am I going to label it as? 17 what? Miles or miles squared? Miles, because it's not an area. Area would be miles squared. So little d is equal to 17 miles. So? Pretty easy? Now, we could actually solve the whole triangle even though it's not a right triangle. You may be given one on your quiz where you have to solve a triangle that's not a right triangle, in which case you have to use the law of sines to find those sides. Because at this point, I now know this is 15, this is 20, this is 17. I know those two angles. I could find the last angle really easily, couldn't I? Just subtract it from 180. Subtract what I know. So I could solve that triangle very easily. Okay? All right, last one. It says to solve the triangle, so let's solve this. To solve this triangle, I have P, K, and H. So I need to find angle P, angle K, angle H, and I need to find little p, little k, and little h. That will be a fully solved triangle. Now, much of this stuff I already know, don't I? Yes? Do I know angle P? What is it? 59 degrees. Do I know angle K? No. Do I know angle H? No. Do I know little p? What's little p? It would be the side opposite big P. That is 30 centimeters. Do I know little k? 35 centimeters. And little h? 17 centimeters. Okay? Now, something that comes up with this type of problem a lot is, I have two angles I need to find, correct? Once I find one, I can subtract from 180 and it's super easy to get that other angle, right? Of the two angles, there is one that is a better choice to choose to solve. And it's the one that looks the least like a right angle. When you come up and you try and find an angle that is close to 90 degrees, there's some issues with your calculator, with the rounding of the decimals and stuff. Your calculator is going to start freaking out if it's too close to 90 degrees or if it's obtuse. Okay? So always try and pick an acute angle that doesn't look like it's really close to 90 degrees. So instead of finding K, I'm going to start off with H. Then I'll just subtract from 180 to find K. All right? I know that's kind of weird, and you may forget that, but you'll come across a problem where you try and find that other angle first, and you're going to be like, wait a minute, my calculator's giving me an error. What do I do? And hopefully at that point you'll be like, oh yeah, Mrs. Franken talked about that one. Do the other angle, and it'll help you get that one. Okay? You'll learn more about why it freaks out with obtuse angles once we get to the unit circle in the next module. So, if I want to find angle H, I have to set up one of my fractions like that. So what is that fraction going to look like? It's going to say sine of H over 17, right? Now, do I want to do sine of K on my next one? No, because I already have something I don't know. I can't have another fraction that has another thing I don't know. I need to have this next fraction where I know both the angle and the side. So what should I use? That one. Sine of P, which is what? 59 over 30. And now how do I solve this? Cross multiply. So 30 times sine H is equal to 17 times sine 59. Well, I can't get H completely by itself yet, but I can get sine H by itself. How do I do that? Divide by 30. So sine H is equal to 17 sine 59 divided by 30, 0.4857, blah, blah, blah. I'm going to call that 0.49. Don't clear your calculator, leave it there. How do I find what H is? H isn't 0.49, the sine of H is 0.49. So how do I find what H is? Inverse sine. When you're looking for the angle, you're always going to have to use that inverse thing. And that will give me H. So, when I have inverse sine, please don't put 0.49. Use this whole decimal. How do I use this whole decimal without having to type it in? Answer. So I have second sine, that gives me the sine -1, and now I'm going to use that previous answer button so that it will give me the unrounded off version. And I get 29.06, which I'm going to round off to 29.1 degrees. Again, please label all of your answers. I need to know whether you know you're talking about a degree measure or something like that. Oops. There's the bell, but I'm just going to finish up this one really quick. I'm just going to subtract from 180 to get that last one. Minus 59 minus 29.1, 91.9 degrees. All right, happy studying.